Okay, from the previous video, you have seen that how a mass spec instrument works in general. Okay, and you have seen that once you inject one sample, what happened to the sample? We call ionization. Okay, so now we're going to move on to the next one, next event, second event we call fragmentation. Let's use methane. This guy. Okay, it's a simple organic molecule. Okay, add into a mass spec, the instrument. This guy will go through the high energy electron beam. Okay, what's going to happen? We call this ionization. Right, so one electron will get knocked off from the molecule, and you get the radical cation. Okay, this radical cation will be deflected by the magnet. Okay, and it go through the detector, so we get this peak right here. We call this a molecular ion peak. It's molecular ion. Okay, and the peak of it right there. Now, if you look up the mass spectrum of methane, there are not only one peak, there are multiple peaks look like that. How do we get the rest of the peak? Right now, we explain only just this peak with a mass per chart of 16. Okay, how do we get the rest of the peaks? Well, this happened. Go back to the molecular ion right here. Okay, radical cation. At this moment, this carbon and this hydrogen are being held together by a single electron, by one electron. How many electrons are in the bond in general? Covalent bond? Two, right? So it should be two bond like that, two electrons like that. Right now, these two atoms are being held by one electron. Is that stable? Of course not. Okay, this guy is really fragile. Yeah, what's gonna happen after? Well, we call this event number 2, fragmentation. It's not stable, so it breaks apart. Okay, start breaking apart, each part start falling off. Right, so in this process right here I show you, so this hydrogen atom take away that electron, this carbon loses 2 electrons total, 1 electron here and another electron from at the beginning the ionization, become a carbocation. Okay, all right, so from one molecular ion breaks apart to 2 species. Let me ask you, which species, the carbocation or the hydrogen atom, which species is detected under mass spec? If you remember, they have to go through the magnetic field, right? Which species get deflected? Only charged species, only this guy can go through the magnetic field. Okay, when you go back right here one more time, make sure you understand. Only charged species can be deflected and go through the detector. A neutral species, like the hydrogen with 1 electron, just hydrogen atom, doesn't have charge. It's go through, hit the side. Of the instrument, doesn't go to the detector. Okay, anyway, I'm going to go back here. So this guy get detected and the hydrogen atom is not detected. So we have the mass of this one carbon, 3 hydrogen is 15 per 1 charge. We call mass per charge of 15. That peak right here, right there, show up that peak. Okay, now the rest right here, so smaller species, so could come from let's say this guy break apart, so this hydrogen grab another electron from this hydrogen, this carbon become a radical, and you get this species mass per shot of 14. You can get mass per shot of 13, 12, or whatever, so we call this fragmentation. So just a bunch of species showing up. Okay, and we detect all of them basically like that. All right, that's a fragmentation. But now go back here. This diagram, this picture, little bit, it's not complete. Okay, as the molecule travel through the mass spec instrument, of course, first of all, it got ionized, become radical cation, which is unstable. It will fragment. So this is not really true. It's not complete yet. Actually, there are a bunch of species going through the mass spec instrument. Okay, mass per chart of 14, 15, 16, 17. That was supposed to happen, not just one species. Now, if you look at right here, right now, the detector catch only the mass per chart of 16, just a 16 one. So we have this peak right here, 16. How do we detect the mass pressure of 15, 14, and others? Well, we're gonna vary the strength of magnetic field. You ready? 1, 2, 3. Now, make it stronger, make it weaker. We're gonna take more and more other species that get 15. Now we get 14. In reality, when you run a mass spec experiment, you will set the instrument to vary magnetic field from this to that, depends on how heavy your sample is. Let's say if your sample weight about, let's say 1,000 atomic mass unit, okay, so you're gonna set this instrument to scan from a small species to a large species, light to heavy, and we detect all these species. You're gonna get all the peak in the mass spectrum, basically. All right, so we got a little video right here. So this is how mass spec work. So start with the sample, go through an ionizer, become a radical cation. This radical cation breaks apart, so you get a bunch of species going through magnetic field. And that only charged species can be deflected, go through the detector, and we detect it. Okay. Anyway, the mass spec start right there, ionization, and then the fragmentation, and then detect later. Okay. All right, that's overview about how the mass spec instrumentation work and event. There are two events in there. Okay. The next one I'm going to talk about get to know the mass spectrum. We're going to start reading. Okay.